Here's a solution for day 3, problem 1. Use synthetic division to divide this polynomial by x minus 2. Synthetic division can be used when you're dividing by a binomial that has a leading coefficient of 1. And that's what we have here. And synthetic division is a way to divide polynomials without having to worry about the variables and exponents, only looking at the numbers themselves. The way this works is to list out the coefficients, starting with the highest degree term and working downwards to the constant term. So the coefficient of x cubed is 1x cubed. Then the x squared term has a coefficient of negative 6. Then the x term has a coefficient of negative 3. And then the constant term is positive 2. So 1, negative 6, negative 3, 2 are the coefficients in order for that polynomial. Now we're going to make a synthetic division bracket. Looks like that. And the number that we're dividing by is going to be written out front. To find that number, we look at that linear binomial and choose whatever number would be used for x so that that is 0. We would have to use 2. 2 minus 2 is 0. And so we write 2 out front. When we divide by x minus 2 with synthetic division, we're writing a 2 out front. So for synthetic division, we're going to run through a process of multiplying and adding numbers together. To begin, take that coefficient and drop it straight down below. Multiply these together. 1 times 2 is 2, and write that result in the next column. Now add these together. That's negative 4. Multiply 2 times negative 4, negative 8, written in the next column. Add these together. That's negative 11. Multiply 2 times negative 11, and that's negative 22. And then add these together. Negative 20. Synthetic division is related to long division, but with long division, you're using a process of multiplying and then subtracting numbers. With synthetic division, we're multiplying, but then adding columns together. The very last number here is our remainder. So it's helpful to kind of separate the remainder from the other numbers that we have. Starting right here, this is going to be the constant in our answer. Working to the left, this is the coefficient of the x term. This is the coefficient of the x squared term. So this is 1x squared, and then minus 4x, and then minus 11. This negative 20 is the remainder. And so a remainder can be written like this. Plus negative 20 over x minus 2. Recall that x minus 2 was what we were dividing by. If you don't like saying plus negative 20 over x minus 2, then this could be a minus sign, and that would be a regular 20 up there. So here is the answer to the division problem. Day 3, problem 2. Evaluate the expressions. Here we have log base 4 of 16. And we want to know what that is equal to. Logs are related to exponents. They work like this. Whatever the base is, you want to figure out what exponent is needed to create that number right there. So you do that by asking yourself a question. 4 to what power makes 16? Well, 4 to the second power is 16, and so this log is equal to 2. Question B. The natural log of e to the 100th power. Natural log is a log with base e to the 100 power. This is another way to write this expression. To find this answer, we go e, which is the base. We ask ourselves what exponent is needed to create this expression here, e to the 100. So e to what power makes e to the 100th power? And that answer is 100. Question C, log base 5 of 1. What does that equal? To find the answer, we take the base and ask ourselves what exponent is needed for this to turn out to be 1. 5 to what power makes 1? 5 to the 0 power equals 1. And so this answer is 0.